Hello! It's time for another lesson in programming using the Prograph visual programming language. Last time we left off, we had discussed how to annotate operations and terminals and routes with controls. In particular, we discussed the repeat operation annotation there. This is an example of a repeating operation. This is an example of a list terminal. These two are attached to each other. That's an example of a loop terminal and a loop route. You can also have list routes. And I think we've pretty much covered it there. This time around, I'd like to discuss the last of the items here under the controls menu, and that would be the inject terminal annotation. Converting a terminal into an inject terminal. Well, what does inject do? Let's take an example here. Let's type in some text. We've created a class called my special class, and when I type that text into an operation, the development environment recognizes it as an example. It could potentially be calling out an instantiate operation for my special class. So it defaults to that and it creates an instantiate operation, which we also call an instance operation here in this case. This text is a bit of an input, if you will, to the operation. It's not data per se, it's sort of metadata, but we can treat it like data just the same. So I'm going to copy this text, and then I'm going to add another terminal to this operation, and I am going to turn it into an inject terminal. And when I do, the text disappears. An inject operation, an inject terminal is a way to supply the needed text for an operation at runtime. So I'm going to double click. I'm going to paste in that copied text. I'm going to hit Command-Shift-C to make that a constant operation. And now this operation needs text to execute properly. It can get the text from us having typed it in, but it can also get the text at runtime being supplied through a special kind of terminal. So let's go and execute this and see it in action. So there's the text, and there is an instance of my special class. So the key here is there are a variety of operations that use text in this fashion to specify the precise kind of operation. And they can be not only the instance operation, but the persistent operation, a get operation, a set operation, the evaluate operation, which we haven't even discussed yet. If I hold down the Option key, I see even more operations that have to do with externals. External get, external set, primitive, we've discussed. If I hold down the Shift key and the Option key, I get external procedure. All of those operations take text, and I believe pretty much in all those operations you can supply that text at the runtime using an inject terminal. So let's give that a shot. My special class has an attribute called last name. And if I type last name in there and hit the return key, it turns into a get operation. This is sort of the default when the development environment recognizes that this text is the name of an attribute. Sometimes you wish it would be the set. If you do a Command-Shift-S, you can turn it into a set. Command-Shift-G back to get. Again, I'm going to copy this text. I'm going to add a terminal. I'm going to paste the text into it. But I'm going to make this terminal an inject terminal. I'm going to create a a set operation, and what do we have here in my special class? Nickname. Okay, well, I'm going to copy that text, put it over here in an inject. Notice I have to add an inject terminal. And what do you say? We get a new nickname here. We're going to call him Tim. There we go. Let's execute all of that and see what happens. We've injected my special class into the instance operation, so we create an instance of my special class. We've injected the name of an attribute of my special class called last name, and we injected it into a get operation, so we get the value of that attribute. And let's just, for clarity's sake, the name was Thomas, last name was Swift, and the nickname was Tom. And now we're going to inject nickname into the set operation, so it will set, hopefully, the nickname attribute with the value Tim. And let's just check on that. And there we go. We've injected Tim. We've injected nickname into the get set operation and provided it with the value of Tim. Getting a little tongue-tied here. So let's continue with all the things you can do with injects. Show is the name of a pretty useful primitive. I'm going to copy that text. I'm going to put a terminal to the left. Now I think with primitives, unfortunately, the terminal has to be to the left. I'm not sure quite why, but we'll just proceed on that assumption. All right. Let's just jump straight to it. Show, oops, we better back up. That's not going to work. Show, hello there. All right, that primitive executed. Let's get back to editing some stuff. Let's try an evaluate operation, a brand new kind of operation which we haven't discussed much. Evaluate currently is a way to get mathematical formulas into your code. Some things it actually is a little tougher to diagram, and text is a good way to get what you're doing specified. Mathematical formula fall into this category, and so for simple algebraic manipulations like a plus b, you can type a plus b in an evaluate operation, and it will evaluate that mathematical expression. So an evaluate operation takes a mathematical formula, generally a basic algebraic one, and every place that you have an A or B, a C, D, E, F, those are placeholders for inputs into that expression. So for the A, we have that A. For B, we have B. If I wanted to add a C in there, I now have 3 terminals. You know what? We might as well demonstrate this in action. Let me add in a 2 and a 3. Get back. Let's see. Back up here. 2, 3. Evaluate. A plus B. We got a 5. Let's back up. and inject this text in there. So let's get off to the side, move these guys over. Excuse me, a little bit of a dry throat. Now, we have 3, we have 2, we have a plus b injected into the text of an evaluate operation, and we have 5. One more thing that we can do, a couple of more things actually. We have a persistent called the persistent. Going to obtain the value of it. Take a look. The value currently is 8. Grab that text. Create an inject terminal. Inject that text. Let's take a look here. Back up. So that works just fine. And what else can we do? Well, we can actually inject the name of a external procedure. I know that the Mac Carbon library has a system routine called sysbeep, and this is something the old Prograph CPX could not do. Sometimes there is a utility in being able to inject the name of a system routine. We'll stick it in there. We'll add 10. Now what sysbeep does is it makes a beep. Very simple little routine. Let's go, I think I need to back up to there. Got the sysbeep, got the 10, and there's the beep, and we're done. So, examples of inject terminals. I didn't quite get that one there. Shoot. Delete it. Oh well. We'll redo it here. I accidentally created a new terminal. Okay. Well, hopefully that gives you a little idea of what inject terminals can do. You can be pretty creative with this sort of thing. For example, you might ask the user to specify a mathematical formula, and then you would just simply inject that formula into the evaluate operation, and why, you'd have a little basic calculator there. Now, we alluded to system routines here, and that's another category of operation that we have yet to discuss. Just to reiterate, in the previous lessons we have pretty much discussed every single item on this list for the controls. Over here under operations, we've certainly discussed methods, constant matches, persistence, and so forth. We finally have discussed evaluate. If I hit down the the option key, though, I see a whole list of new things. We've discussed primitives. There are no such things as external globals and structures yet. External structure is just not something we need. There's a way around that. External globals, most code these days doesn't need access to those, so we have yet to put that in. But it's time to discuss externals now. In order for your program to do anything useful, it has to interact with the hardware of your computer. And that access to that hardware is provided by code that the manufacturer, Apple, Microsoft, the operating system designer, developers have provided. And generally that access is through what I'll call generically system routines. And This is code that is wrapped up typically in a package called a library, or on the Mac a framework. On Windows it would be a DLL or a lib, and your code can access those libraries, use those system routines, and do the things that really make a program useful. You'll draw to the screen, you'll see what keyboard input is, you'll make sounds. All of that is done through system routines, so it's very important for any development environment to provide access to these system routines, otherwise there would be no useful applications created. Well, we provide a variety of system routines, most of them on the Mac, but we do provide Windows as well. And over here in our list of libraries of this project, we have the standard set of primitives, things like plus and minus, logical OR, a variety of primitives. Typically you can double click them and get a little documentation on it. If you're using a later version of the Mac operating system, this may not show up because Apple over the years has kind of broken a few things. But you can find the documentation inside the application, the Marten application resources folder. You need to know how to go inside an application, but it's tucked in there. If I double click the Carbon framework, though, I don't see a list of any primitives. What this framework provides is access to the system routines that Apple first started out on Mac OS X with, and those were called the Carbon library. More recently, Apple has deprecated and basically made it very difficult to write Carbon applications anymore. They've moved everybody over to the Cocoa library. And then, of course, on Windows, Windows 7 and later, we have system routines for creating Windows applications. And also, we've created some primitives. A lot of these have to do with the Direct2D drawing. It's just a lot easier to write a primitive than try and create the system routine interface. We have some other primitives here: get high word, get low word, get current module. Those are all useful. And in a later lesson, when we design Windows applications, we'll go into their use. But for now, you get access to those system routines by knowing their names, basically. We do not provide a list of them. And they should be there. If they're not, you can certainly contact us and ask us if we're missing any. Perhaps at some future time we'll create a list of all the system routines. They number in the thousands, which is why each one of those libraries, we just don't list those routines out. So here's an example of a Windows 7 system routine. You have to know this name to get to it. You can look it up in Windows documentation, which is typically what I do. If you double click it, you will get some basic documentation, which pretty much tells you the types of things you should be providing as data on the terminals. This has 12 inputs. It returns a pointer to a window structure, and the outputs are not something we necessarily need to worry about at this point, these final 4 roots. An example of a Carbon routine, well, we already had sysbeep, but let's put it in there again. And let's just execute that. We're not on a Windows platform, so executing this actually doesn't do anything. It might even make things crash. So there's our beep. A more useful system routine would be cfurl get string. and we can get a little basic documentation. It requires a pointer to a CFURL, core foundation URL structure, and it returns a pointer to a core foundation string. Again, this is very low-level programming, and as a developer, if you're going to use these system routines, you need to consult the documentation for the platform in question and the library and so forth, and basically learn the library. We don't provide a lot of help other than if you type in the name correctly, it'll show up appropriately, and we provide a little basic documentation. Finally, we have access to the COCO library, and the COCO library is an object-oriented library that basically is manipulated using the Objective-C language, which of course we don't have Objective-C in Prograph, we just have Prograph, but we do provide access to Objective-C objects. Let's debug this and jump right to it. And if I run it, you'll see that I've created an Objective-C object. Now this Objective-C object actually is an instance of an NS application class, and down the road we'll provide a little better view into that. Right now this isn't very useful. An example of a COCO system routine would be the run method for an NS application object. And if I were to connect those two, and if we were to execute this program, it would run. In fact, we should just perhaps see what happens there. So let's debug this. Now before I do this, I'm just going to say that's the end of the discussion, because once I run this, Objective-C is not going to let me get back to the Marten environment, and I'm afraid I'm going to quit it and everything will shut down. So in a future lesson we'll discuss how to get around that. In this lesson we've discussed the inject terminal. We've briefly shown you how to use the evaluate operation, and we are about to demonstrate, I hope, some use of external procedures. We haven't talked about external get and set. You know what, I guess before I do that I ought to discuss it a little bit. We don't have external structures. We use the make external primitive. In Windows there's a thing called a point, and we provide a size of operator, and we can now create a block of memory that represents a point, and there is an X external set. There we go. And I might say the X position is 10 and the Y position is 20. In a future lesson we'll discuss this in much more detail. And so this would be a way to create an external structure which we don't have an operation for. We just do it using primitives, and then once that structure is created you can access its fields with the external get and set. Let's make that an external get. Okay, now back to running here. We're about to run this. Let's see what happens. Well, look, Hello World is running. And you know what? When I quit it, everything is going to shut down. So before I do that, I'm just going to sign off, and we'll get to the next lesson soon.